Hi everyone, this will be your video for this week, which is Arithmetic Sequences. You can follow along with the guided notes page, fill in the answers as you go, and then use the examples to complete the practice and homework problems. So here we go. We have arithmetic sequences. So last week we did learn about geometric. This week is arithmetic. They are similar, but they are very different. So when we're looking at an arithmetic sequence, it's a sequence when the difference, so it's a little bit different than a geometric. Now we're talking about a difference between consecutive terms is a constant. So there we go. It's a difference now. And you can see that now we're going to use this idea of what's called a common difference. When we're learning about geometric, that's a common ratio. Here we have a common difference. So what this means for us is that if we take any term, okay, and we just have to be careful because it can't be the first term. Oops, so we're going to write not the first term. Okay, so you can take any term and you're going to subtract its previous term. And that's going to help you find your common difference. So for the example at the bottom of the screen, or the next example that you see, it's just asking you to find the common difference. So we're just going to take any term. So I'm going to start with negative 21, and I'm going to subtract its previous term. So notice how I use parentheses here. You want to be very careful when you're subtracting, especially if you are subtracting negatives. So we could actually rewrite this as negative 21 plus 27, because when you're subtracting a negative, it becomes addition. So if you learn the phrase like add a line, change a sign, this is where that works. So we have negative 21 plus 27, and that's going to give us 6. Now, if you chose any of the other values here, you would also get 6. So our common difference will be 6. There's an additional note I'd love for you guys to take, and that's to verify if a sequence is an algebraic arithmetic. So here's our note here, is that to test if a sequence is arithmetic, check all common differences, okay, they must be equal. So if you were to just test to see if a sequence is arithmetic, you would just find all your common differences and you'd want them to all be the same. So for instance, if we were testing this sequence, we would test all of our pairs and we would say, okay, if negative 9 minus negative 15 is 6, and negative 15 minus negative 21 is also 6. So we could definitely say that this is an arithmetic sequence. So down on the bottom half of this page, we're going to start writing rules. And we have two different options. We have recursive, which relies on a previous term. So recursive relies. And then we also have what's called an explicit rule, and that's going to be on the next page. So let's talk about recursive first. And I already have it filled in here. So you have your rule, and you figure out how to write this because you're going to take your previous term. That's what this a sub n minus 1 is. It's your previous term. And you're going to add your common difference. So the only time you might see a different here is this might look like a minus sign sometimes, and that's just if your common difference is negative. So if it's positive, you see a plus. If it's negative, you see a minus. Another thing you want to take note of is that when you do have an arithmetic sequence and you're making it a recursive rule, you need to show what your a sub 1 is. And that's already typed in here for us, but it's an important fact that you need to show what your first term is. So let's look at this next example, and they're going to ask us to write the recursive rule for the sequence and find the next three terms. So the first thing that we can try to find is our d. So our d is our common difference. You can choose any term, so I'm just going to choose 7, and you're going to subtract its previous term. So when I do this, I get 5. And you can see that, for instance, if I chose 12 and I took away 7, I would also get 5. So that's telling me that d equals 5. So I have that piece of the puzzle. What I need to do now is I can write a sub n equals a sub n minus 1. We don't know what that term is. It's just the previous term. And we know that our d is 5, so we'll write this as plus 5. Now, we also need to say a sub 1 equals, and our very first term is the very first one that you see here with the ones that are typed, and our very first term is negative 3. So this is our rule. And then we could use this rule to find our next term. So for instance, this is when n equals 1, 2, 3, 4, 5, 6, 7. So we're trying to find a sub 5. That's our next term. So we're going to take a sub 5 minus 1 plus 5, which means I'm going to take a sub 4 plus 5, which is 12 plus 5, and we get 17. So you can clearly see we're just going to take that term and add 5 to it. So our next term would look like 22, and then our next term would be 27. So a recursive rule relies on a previous term. On the other hand, we have explicit rules. So here you go, it's already written in again. So a couple things that I want to take note of is that this is still our first term. And this n, that's the number term we're looking for. So this is our term number. Okay, so they all still mean the same thing that we've learned for the past few weeks. So just to reiterate, a sub 1 is your first term, and n is the number that you're finding. So you can see on this example, this next one that we see, they're giving us a sequence, and then they're asking us to find the 32nd term. So our last problem was easy because we only had to find the next 3 terms, so that was fine. But now we would have to find the 32nd term, so we would have to keep adding 32 times, which we don't want to do. So we're going to write an explicit rule. So the things I need to find are my d value. So d equals any term, so we'll just take 40 minus the term before it, and we get 8. So our d value is 8. We're going to take that, and we're going to plug it into our rules. So we have a sub n equals a sub 1 plus n minus 1 times d. I'm just writing it again so we know what we need to fill in. And if you notice, we have a d value. We will have something for here, but we still need to plug in what a sub 1 is. So let's just write that on the side so we have it. A sub 1 equals our very first term, so 32. So we can write a sub n equals 32 plus n minus 1 times 8. Okay. So this 8, even though it's on the right-hand side of the binomial, it is still getting multiplied or like distributed to what's in that binomial. So it's going to look like a sub n equals 32 plus 8n minus 8. And then you can simplify what you can. So we can do 32 minus 8, and we'll get a sub n equals 24 plus 8n. So this is our rule here. And remember, rule just means an equation. Okay, and then we are asked to find the 32nd term. So all you have to do is plug in 32 for n. You just want to make sure that you are writing the correct notations. I'm just going to do it up here. So a sub 32 equals 24 plus 8 times 32. So I'm plugging in my 32 for n. I get 24 plus 256, which gives me 280. So my 32nd term would be 280. So can you imagine having to add 8 until you get to the value of 280? So that would take so long. So this rule is really helpful where you can find this really term in the future that you just don't want to have to do the work to get to. So we can graph these as well. This is our last little topic on this guided notes. And we're talking about how the graph looks. So when we're talking about an arithmetic sequence, what we're working with this week, what's nice is that all the points will lie on a line. Okay, so when you graph your points, they should line up pretty nicely. You should maybe even be able to use a ruler to draw the line, and you'll know that that's correct. So last week was a curve. So remember, a geometric sequence makes a curve, and arithmetic makes a line. So when we're filling out our table, you can see that we're going to plug in our n value and then solve. So this would become -2. If we were to find a sub 2, we would get -6 plus 4 times 2, and we get a +2. And you can always take your time. I just don't want to make this video longer than it needs to be. So we're going to plug in 3, and we get 6. We have a sub 4. We're going to plug in 4, and we're going to get 10. And then we plug in 5, and we'll get 14. So these are all points. Remember, it's n, comma, a sub n. That's how you can plot these points. So the first one is 1, negative 2. My second one is 2, 2. My third one is 3, 6. And you can see they're nicely going in a line. 4, 10. 5, 14. So we'll be able to connect these. And this problem's done. You can see it's a nice line. You can even tell the rise and the run. It would be 2 blocks up, 1 block over. That's the same for all of these points. So that's indicating that this is a line. So I do suggest referring back to these guided notes when you're working on your practice problems. If you have any future questions, just make sure you reach out, and good luck.